Okay, so I think you cannot see my screen yet. No? Yeah, so confirm guys if you're able to hear me clearly and if you can see the screen also. Guys, can you hear me?
Yes, sir.
Audio clear? There is no disturbance or anything, no? Okay. So let's wait for just 1 more minute and then we'll start, okay?
Sir, you told that today you will clarify my doubt.
Yes, yes. Okay, so let's start with that, Nitya's question. Nitya, can you read out your question? What was your question?
One minute, sir.
Yeah. Okay.
Sir, show that there is no positive integer n for which root n minus 1 plus root n plus 1 is rational.
Okay. So we have to show that there is no positive integer, right?
Yes, sir.
For which root n minus 1 plus root n plus 1 is rational. It cannot be rational. That's what we have to prove it. Okay, so I think let's get started with this problem. Anyone knows how to solve this? By the way, anyone?
Sir, we can take a plus b.
Mhm. Say that again. Charan, I couldn't hear you. Was that Charan?
Sir, a minus b the whole square.
A minus b whole square. Okay. What do you want to do? I didn't get your point. Sorry. Like we have to prove that this is rational or rational, whatever. Okay. How do you prove that this is rational? This is not the Euclid's division algorithm. Remember, that kind of problem will tell you that you have to prove some divisibility, that this number is divisible by something. So this is not that problem. This is about proving this as rational or irrational. Okay, so like we always do, when we have to prove something that it is not rational, that is, it is irrational, it cannot be rational, then we assume the opposite, no? So we'll do the same thing here also. Okay. Let's assume that square root of n minus 1 plus square root of n plus 1 is rational. So if something is rational, we should be able to represent it in some form, no? P by Q form. So let's write it like that. And we should be able to write it like square root of n minus 1 plus square root of n plus 1. And this we can write it as P by Q form. where P and Q are what? What is P and Q here, guys?
Sir, why isn't it A by B? Like, are they same? You're taking that?
See, we can call it as A by B or P by Q, anything. So yeah, like in last few problems which we have solved recently, we used to take A by B because I used to call this as co-primes, and we used to prove that they don't have any common factor in between them, right? We used a problem where we assume that A and B are co-primes. That means they do not have any common factors. And then later on, we showed that they have some common factor, like root. In case of root 2, when we had to prove that root 2 is irrational, we showed that both A and B are divisible by 2, so they cannot be co-primes. Okay, so in that case, we used to call it as A by B, and we need to take them as co-primes, but that's not the case always. Okay, so here we don't need to consider them co-primes because considering them simple integers is more than enough. Okay, so we'll just take the P by Q form where P and Q are integers. This is just considering them integers is sufficient for this problem. We don't need to worry about co-prime over here. Okay, we're not going to talk about factors of anything. Okay, so Hari is messaging me. Hari, are you facing any problem?
No, sir, I was sending you the answers of that test.
Oh, okay, that's okay. Fine. So everyone is okay so far. I've not done anything. I've just assumed that it is rational, and then if it is rational, I'm writing it in the form of P by Q, where P and Q are integers, and you know that Q should not be equal to 0 because Q is in the denominator. So denominator should never be 0. That's why we specifically mentioned this. Anyway, so once we are done with that, what we can do? Anyone can still think of something? Can you think of any approach how we can prove, how we can arrive at a contradiction here?
Sir, we can, like, can we simplify that root n minus 1 by taking out the roots? The identity is there, a square minus b square.
Okay.
Sir, but plus is there in differential.
Yes, sir. Plus is the.
See, we have in similar problems, what we used to do, we used to move one of the roots to the other side. If we do that, the right side will still have this kind of square root, no? So we will have irrational left hand side and irrational right hand side. This cannot be proved like that. Okay, that approach we cannot take here because n can take any value over here. Okay, there is a variable inside your square root. That variable is n, and this n can take any value. So we will not be able to decide whether n minus 1 is rational or irrational. We cannot tell that. Depending on different values of n, it could be rational or it could be not a real number at all. It could be something else also. Okay. So that approach will not work here. This needs a different kind of solution. So let me tell you what we do here. Yeah, anyone wants to say something?
Sir, can we square on both sides?
If we do that, it will not work. Because for the same reason, I'm telling you that there are variables inside this. If there were simple numbers, we will know that something is rational or irrational. Like instead of if you had something like this, square root of 2 and 3, and then p, then if you do the squaring, you will be able to get the contradiction what we normally get. But because there is no specific numbers inside the square root, there is n and n minus 1, n minus 1 and n plus 1. Just squaring will not help you. Okay. So if you want, you can give a try to that. Try to square both sides and see what happens where you get stuck. Okay. You will try that at home later. Okay. But for now, what I will do, let me call this as first equation. Okay. So square root of n minus 1 plus square root of n plus 1. I'm calling it as p by q. Let's do a reciprocal of this. So what will happen? This will become square root of n minus 1 plus square root of n plus 1, and this will become Q by P. Why am I doing this? That will start making sense after some time. Okay, just hold on. Okay, so now you see that the denominator has become it is like square roots in the denominator. So there is a chance it is irrational. Do you know how to rationalize the denominator? The approach we used to take. If we had root 2 plus root 3 here, how would you rationalize this denominator? Do you people remember that?
Root 2
We have to
minus root
multiply
3.
with the opposite sign.
Yes, the opposite sign, that is called conjugate. So here it is square root of root 2 plus root 3. The conjugate of this will be root 2 minus root 3. What is it called? It's called the conjugate of this. So we multiply the same thing in denominator as well as numerator. Okay, so same thing we will apply, same logic will apply here also. Let's do that. Okay, so what will be the conjugate over here? There is square root of n minus 1 plus square root of n plus 1. So the conjugate of this number will be square root of n minus 1. Tell me guys, what will be the conjugate? What should I write?
Minus root n plus 1.
Yes, minus root n plus 1. Excellent. And in that same thing, we'll have to multiply in the numerator also. So I will do n minus 1 minus n plus 1. And here, this is just same q by p. Okay. Let's simplify this left-hand side. So numerator will be just n minus 1 minus n plus 1. And this, I can write it as, what should I write the denominator as? Tell me. This is a plus b into a minus b, right? This is a, and this is your b. So this is a plus b into a minus b. So what will be the new denominator now? It will be a plus b.
A square minus b square.
Yes, it will be a square minus b square. So let's do that. So first I will make the spot for a square. This is where I will write a square minus, then I will write my b square. So what is my a first of all? My a was square root of n minus 1, correct? So what will be the square of square root of n minus 1? It will just be n minus 1, correct? Can I write that directly? N minus 1. All of you understand? The square of square root of n minus 1. It will become, the square root will get removed, right? Simple. We are doing a square of that. And then there is a minus. So let me put it inside a bracket, and this one also. And what will be b square?
N plus 1.
N plus 1. So you people understand what I'm doing, right? Confirm quickly, all of you. Everyone okay up to this step?
Yes, sir.
Okay. I'm waiting for other people.
Yes, sir.
Okay.
Yes, sir.
Sir. Yes, sir.
People are like very, very silent. It feels like they're not even there in the class. Manoj, not hearing you. Adi, where is Pragati? Tanushri, not hearing anything from Pragati for so many days.
I understood.
Pragati, are you there? Yes. What, Pragati? Are you there or you're watching TV, keeping me on mute? No, I was not able to hear you. Tanushri, are you there?
Yes, sir. Can you hear me now, sir?
Yes, I can hear you now. You understood whatever we are doing so far?
Yes, sir. Yes. Sir. I was telling you, sir. I was replying you, but I think you can't hear.
Okay.
Now
that's
it's clear now, sir.
Yes, yes, yes. That's okay. Okay. So I think Pragati has some mic problem. Okay, Pragati. Try to get some headphones, all of you. Okay. Yeah. So Yeah, what we did a reciprocal and then we multiplied with the conjugate to rationalize the denominator. Now let's simplify the denominator here. What happens to the denominator? Can you tell me, guys? What should I write in the denominator? Numerator will be square root of n minus 1 minus square root of n plus 1. That's our numerator. What happens to the denominator? You can tell me.
-2, sir.
Yes, it will be n minus 1 here as it is, and then this minus will multiply with both of them. So it will become minus n and minus 1. So as you can see, this is plus n and minus n will become 0. Minus 1 and minus 1 will become minus 2. So yes, Kavya, you're right. It will be minus 2 in the denominator. Okay. So that minus 2, what I can do, I'll send it to the other side. Or else I can, instead of sending the negative sign this side, I don't want to make this side negative. Keep that, let's keep that as positive itself. What I will do, this minus sign, I can send it to the numerator, no? So what will happen to the numerator if I send a minus sign from here? Something which was positive will become negative, and something which was negative will become positive, correct? So can I write it as square root of n plus 1? This will come first, and now this one will become negative, square root of n minus 1. And the denominator was 2 now. See, minus 2, I send the minus to the numerator. That's why this got flipped. Instead of n minus 1, I have got a n plus 1 here. So this is simple. Like, do you people understand what I did? You had a minus b by minus 2. So this minus I sent here. So this minus, because of that, what will happen? It will become minus a plus b, no? This is what I'm just interchanging, and I'm writing it as b minus a by 2. So quickly confirm, all of you. Do you understand what's happening here? I've just sent the minus sign to the numerator because I don't want to write negative number on the right hand side. I don't like
Sir,
negative.
I didn't understand the minus which is there before root n minus 1.
Mhm. Okay, let me explain this better. Okay, hold on. So what this analogy you are understanding? No? Consider a as your square root of n minus 1 here, and b is your square root of n plus 1. So there's a minus sign in between them. You can understand related to that example now?
Yes, sir.
Okay, so now let's see here. It's the same scenario. There is a minus b and there is a minus 2 in the denominator. What I am doing actually is I am multiplying with minus sign on both sides. Up also multiply minus, down also multiply minus. We didn't change the number, no? When we do the same operation on both numerator and denominator, we don't make any change. So denominator will become plus 2 now. What will happen to the numerator? It will become minus a plus b, correct?
Yes, sir. I understood.
Okay, so this is what minus a plus b. I'm writing it properly as b minus a. We can write it like that also, no? B minus a by 2.
Yes, sir.
Okay, so that is what I did here. There is a minus b, but after multiplying the minus, I'm writing it as b minus a. Okay, everyone understood this? Confirm, guys? Still processing.
Understood, sir.
Okay, good.
Understood, sir.
Okay, that's okay. So just understand that this n minus 1 has come to the right hand side, and this n plus 1 has come over here because we multiplied with the minus sign. Okay, with all that, I'm just not going to write another step. So I'm just sending the 2 directly over here. So it become 2 cubed. Is that okay with everyone? And I'm going to call this as equation 2. Okay, actually solving this problem after we have completed the third chapter, no, the pair of linear equations would have made more sense because we need to use that logic over here. So anyway, for now, I'll just solve it for you, but you will understand it better once we are done with the third chapter. Okay, so you see what is happening here. What was the first equation when we started? It was square root of n minus 1 plus n plus 1. This thing is equal to p by q. So let me rewrite that equation down again over here. And again, since there is a n plus 1 written first here, so I will write that first equation also as n plus 1 here. And then there is a plus sign and then n minus 1. And that was equal to p by q. I'm just rewriting the first equation again. I have just reversed the order. A plus b can be written as b plus a. Okay. Now, whenever you have a situation like this, what we can do is we can add these two equations. If you add these two equations with each other, do you know what will happen? You see, this is minus of n minus 1 and this is plus of n minus 1. They'll get cancelled and become 0, correct? So I'm adding 1 and 2.
Sir, why are we adding?
You will understand. Have patience. Let's see. Okay, but that's a good question. You should know why we are doing it, but let's see what happens, why we are doing it. Because there are two different numbers. I want to eliminate one of them and I want to have only this plus square root of n plus 1. So now if you add them, what will happen? It will become 2 times of square root n plus 1. No? 2 times of root n plus 1. And these two will become 0. So I'm not going to write it on the LHS. What will be the RHS? I have just added, so it will be 2q by p plus p by q. Understand that when we add equations like this, you add the LHS with the LHS and the RHS with the RHS. So this is the RHS of first equation, RHS of the second equation. I've just added them together. And in the LHS, what happened? These two got added together and became 2n plus 1. I mean, 2 root n plus 1. And these two got cancelled and became 0. So tell me, are you okay with this up to this step?
Yes, sir.
Yes, sir.
Okay, good. Then you have almost completed. Now, just move this 2 to the other side again and simplify this also. So it will be square root of n plus 1. And I'm going to do that together. So let's keep this 2 as of now here. Simplify this. What will happen? Cross multiplication. It will become 2q square plus p square by pq, correct? Everybody knows how to add fractions. When you have fractions like this, what we do cross multiplication. Multiply this with this and right here, and multiply this with this and right here, and put the sign. If there's a plus here, put a plus here. If there's a minus, put a minus. And denominator will be just the product of the two numbers, p and q. Means whatever is in the denominator, the two things. We'll multiply and put it over here. Okay. Everyone okay with that addition of fractions?
Yes, sir.
And then, of course, what I said, I will send this 2 also to the denominator. So I'm going to do that in this step itself. Let me write that 2 over here. So this is something which we got. I have got one particular value where square root of n plus 1 is some rational number. This right hand side is rational. Can everyone understand that? That it is a rational number? Because
Yes, sir.
because p and q are integers, remember. So if p and q are integers, this numerator will also be integer because p is integer. So p square is integer. This is also integer. Integer plus integer also becomes integer. So numerator is integer. Denominator is also integer, means there is a p by q form. So this has to be a rational number. So RHS is rational, but do we know that LHS is irrational over here right now? Can you tell that LHS is irrational at this point? Can we say that? We can't, because if we had a particular number like this, root 2, then we can say that we know that root 2 is irrational. But what if, imagine if that n was equal to 3. So if n was equal to 3, then 3 plus 1 becomes square root of 4 and this becomes rational number, no? So if n is equal to 3, then it will become rational. But if n is equal to 2, then 2 plus 1 becomes 3. So this becomes irrational. So there is no fixed thing. We cannot say that n plus 1 is always rational or always irrational. It depends on the value of n. Depending on the value of n, it could be rational or irrational. So we cannot say anything about this as of now. Okay, but we for sure we know that RHS is rational. So let's keep that in mind, and let's do one more calculation. See, and that calculation we are going to do with this first and second equation only. When we added, what happened? These two got cancelled, and we got the value of square root of n plus 1. Now what I'm going to do, I'm going to subtract the second equation from the first one. So if I do subtraction of these two, what will happen? The sign will change. This minus will become plus, and this plus will become minus. I'm going to do subtraction of 1 minus 2. Remember, that's why I'm changing the sign of this guy over here. Okay, I'm going to do 1 minus 2. So n plus 1 and n plus 1 will get cancelled, and this time square root of n minus 1 I will get in my LHS. Okay, so let me do that. Let me write it properly. So since you asked me this question, I'm solving it right now. But what you can do after completing the third chapter, which we are going to start now, pair of linear equation in two variables, we will come back to this question again, and you will understand how I am solving this. This is also actually a pair of linear equation in two variables. We are using the logic of the chapter 3 to solve this question over here, which you have not studied so far. That's why it may seem a little difficult for you. But if you are totally, interested in doing this right away, then you can go through the video and try to understand whatever I have said. Okay, so it should make sense. So what I'm going to do now, I'm going to do 1 minus 2. So 1 minus 2, what will happen? N plus 1 and n square root of n plus 1 will get cancelled, and this will be 2 times of n minus 1 will be there inside. So 2 root n minus 1 is there. And what will be the RHS? This you should be able to tell me, guys. If I do 1 minus 2, what will be the RHS? One minus 2. Is it very confusing? Do you want me to stop it here? Do you want to come back to this later after completing third chapter?
Yes, sir. Yes, sir.
Okay.
Minus 2.
Okay. So we are very close to solving it. So just bear it for a couple of minutes. Let me just finish it. So if anyone needs it, they can go through the video, and those of you who are not able to understand it, don't worry. I'm not expecting you to understand everything as of now. Okay, don't worry if you're not able to understand. So this will be, I'm doing 1 minus 2. So I will write p by q and then minus of this thing, 2q by p. Minus of 2q by p. And simplify the RHS like we did last time. It will be same thing, cross multiplication. So tell me, guys, what should I do here? Cross multiplication, what should I write here? This is not complicated. This you should be able to tell me.
Minus 2q square plus p square.
It doesn't have to be in that order exactly. We can do this first and then this. Okay. So we can write p square.
P square minus 2q square by pq.
Yes. Okay. Because this one has a minus sign, so I don't want to start writing minus 2q square. You can write it. There is no difference between writing this. Okay. This is the same thing as a plus b and writing it as just changing the order of addition. It doesn't matter. Okay. So since this one is positive, that's why I'm writing p square first and then I'm writing 2q square. And again, sending the 2 to the denominator, what will happen? It will become 2pq here. So this one I have got as square root of n minus 1. Okay, so as you can see, I have found the values of square root of n minus 1 and square root of n plus 1. And I'm seeing that both of them should be rational. Because their RHS is rational, so both of them should be rational according to our assumption. But the contradiction here is that both root of n plus 1 and root of n minus 1 at the same time they can never be rational. Square root of n minus 1 and square root of n plus 1 cannot be rational for same value of n. That means at the same time they cannot be rational. But from equation 3 and 4, okay, the order how we should write it is like this. Let me write it. From 3 and 4, square root of n minus 1 and root n plus 1 should both be rational. But they cannot be rational at the same time. I'm going to explain why they cannot be rational at the same time. Let's see. See, if you put any value of n, we write both of them, square root of n minus 1 and square root of n plus 1. I'm writing both of them. Try to keep changing the value of n. N is a positive integer, so you'll have to start writing with n equal to 1. Okay. So if you put n equal to 1, what happens to this guy? What is the value of square root of n minus 1? Square root of 1 minus 1, that is 0, right? And this, see, this is rational. If I put n is equal to 1, I'm seeing that 1 minus 1 becomes 0. So square root of 0 is also 0. So it is 0. This is rational. Okay, very happy. But for the same value of n is equal to 1, can this be also rational at the same time? Let's see that. If n is equal to 1, then 1 plus 1 will become root 2. And as you can see, this is irrational. Okay. Now let's try n is equal to 2. So this is 2 minus 1.
Sir,
Yes, tell me.
sir, so both can be irrational, no, sir? Like, is there a chance?
Yes, both can be irrational. That is okay. They can be irrational, but both of them cannot be rational at the same time. What do we need? From our third equation tells us that root of n plus 1 should be rational. And fourth equation tells us that root of n minus 1 also should be rational at the same time. When we take any value of n, both of them should be rational because we have such kind of value. The value of square root of n plus 1 is this much. The value of square root of n plus 1 is this much. So it should be rational. That is what we have found out. And this also should be rational. But what we are seeing that if we actually try to put some values of n, we are seeing that both of them, n minus 1, square root of n minus 1 and square root of n plus 1, both of them can never be rational at the same time. So that's the contradiction here, okay? So as you can see, if you put, I was trying to join. So this is 2 plus 1. So this becomes root 3. So you can see this is rational, but this is irrational again. You see with n is equal to 3, it will become 3 minus 1. So this becomes root 2. This time this one has become irrational. And let's see, if I put 3 plus 1, this becomes 4 and this becomes rational now. You see, if this guy becomes irrational, this turns to be rational. So both at the same time can never be rational. That is how the nature of root of n minus 1 and n plus 1 is. Why is that happening? Because there is a gap of two numbers between them. You see, n plus 1 and n minus 1, there is a gap of 2 between them. No? How much gap they have between? These are numbers, no? Simple numbers. Do a subtraction and see. They have a gap of 2 in between them. So do you have any perfect square numbers, since they are inside the square root? Are there any perfect square numbers which are 2 units apart? No, right? 1 is the perfect square. After that, 4 is the perfect square. After that, 4 it will be 9, 16, and so on. So the minimum gap between the perfect squares has to be 3. So if you have numbers like this within the square root where there is one of them is n minus 1 and other one is n plus 1, so there is a gap of only 2 between them. So both of them can never be perfect squares. Okay, so that's enough for explanation for this much, this question, guys. Okay, don't worry if you're not able to understand, but since you people asked it, that's why I solved it. You will, don't think you will get this kind of question in your board exam. Okay, so but this will start making more sense when you complete the third chapter. Okay, so that's the contradiction, that both cannot be rational at the same time. Therefore, our assumption was wrong, and there is no value of n for which that can be rational.
Sir, the question says that there should be no positive integer, so it can be negative.
Okay, see, if I write square root of n minus 1 and square root of n plus 1, they are saying that there is no positive integer n for which this becomes rational. So then you're asking, can there be any negative integer for which both of them can, this can be rational? I have not checked it, but let's think about it for a minute. Can we have negative numbers which will make the both of them perfect squares? No, I don't think so. There is no negative number also which will make it this n minus 1 and n plus 1 both cannot be perfect squares at the same time. And unless they are perfect squares, this will never be rational. No? For a number inside a square root, it can be rational only when it is a perfect square. So can both of them be perfect square? Is it possible? I don't think so. So if I put n is equal to minus 1, what happens here? This becomes negative. So square root negative root of minus 2, it will become an imaginary number. So there is no need for going there. Okay, so there's no positive or negative number like that. But we don't worry about negative numbers because that makes the number imaginary. The number will not be real anymore. And you know that you don't have to study about imaginary numbers right, as of now, no? That's why they have mentioned specifically that the number is positive. Okay, so we have finished the whole class in this problem. So that's okay. I know that this will be difficult for you people to understand, but still going through all this, there is a reason I have still explained it to you people. So try going through the recording and see how much you can understand. It will help you, okay, in some ways. Okay, so that's enough for the maths class.